Good morning, good afternoon, or good evening, whichever you may happen to be, wherever you may happen to be, even, and whether you're watching live or archived. And welcome to another Nautel Transmission Talk Tuesday. This is episode number 43, according to my screen, and we're making progress. I've still tweaking it on whatever we're going to do for a party when we hit 50, but we're going to have some fun. I've got another good friend with me today, and we're, like I say, we always try to find somebody that knows more than me to talk about. That's usually not that hard to do. And today I've got my good friend Kirk Harnack from Telos Alliance. Kirk, welcome, and thanks for being with us.
Thank you for having me, Jeff. It's delightful to be here. You haven't been traveling in your sales area much, have you?
So I have been grounded for about, let's see, I want to say a year and a half now, just about
Uh,
exactly.
uh,
Um, And I'm going to apologize for the cameras, folks. For whatever reason, the one I usually use is deciding to switch on and off. So you may be getting different shots here and there. I'll just try to follow the little bouncing light as we go. But no, this is the longest I've been in one place since I was 16 years old.
oh my
Um,
goodness. This is before you had a
because I
car, right?
well, always, because I've just always, we've always traveled or gone visiting and done stuff. So yeah, it's not normal for me to sit in one place. The plus side, I've discovered that I actually enjoy it, and I might actually be able to retire someday and not drive my wife totally crazy. Um,
Hey,
the other
y'all learning to
plus,
get along during
well,
COVID?
she seems like a really nice person. It's been fun getting to know her a little bit. So
That's
no, we've been having a great time. Now, you know, I am going to prompt you because when we were doing the little preamble, you mentioned you had a part-time job once, and
well, yeah. I've got two kind of sad stories from the last couple of weekends. Really the saddest one was, and the reason I asked if you were traveling because I know you travel from north to south, over the central part of the U.S., right?
correct.
Yeah. So you're way up in the north sometimes, you're way down south. New Orleans is in your area, right?
It is. It is.
Yeah. And they have lots of Cajun cooking. And you ask people, do you like Cajun cooking? Almost everybody says yes. Although I actually
Mhm.
saw my chiropractor this morning. I really did. This is true. And it's not a story. And I said, yeah, I said, Jeff, do you like Cajun cooking? He says, I'm a vegetarian, Kirk. Yeah, I think you know that. Not much
Yeah.
vegetarian. But so this past weekend, I got hold of some alligator meat and I was going to cook some alligator meat. And I totally failed. I couldn't do it. I mean, it's in the fridge now. I don't know what I'm going to do with it because all I have is a crock pot.
All right.
I, I'm sorry. I'll keep my Telos job as long as they'll have me, and as long as I don't tell too many jokes like that. But on the other part-time job, sometimes I do weather on TV, but they haven't needed me in a while. So
Mhm.
I've been working on the weekends as a butcher, and but I had an accident Saturday afternoon. I backed into the meat grinder,
Uh-oh.
and after that, I got real behind in my work.
All right, on that note,
All right.
folks, we are just going to carry on with this
Has the
before we
attendance
get
dropped
ourselves.
now? Has it dropped? Have we done our job?
Let's see. Actually, it's gone up a little. The rumors must be going out there. And
Poor unsuspecting souls.
one of our sales guys throwing his own dad jokes. He said, "You get you some cast iron." I'm not 100% sure he got that joke, but that's what happens when you tell a joke to sales guys. So mandatory housekeeping stuff, Nautel webinars as with, well, all of our TTTs, all of our webinars do qualify for half of a SBE recertification credit under category I of the research schedule. If you're an SBE member, then make sure you jot that down wherever you keep track of your recertification. Reminds me, mine is up next January. I think I should start my little list. Um, and if you're not an SBE member, why not? Come on, it's there are some benefits. You even get to talk to smart people like us on occasion. We have a whole lot of fun. Uh, let's see, I haven't checked. Wayne Pacino from the SBE, our president, usually joins in, but if he's not there, shout out to Wayne and the folks over there for doing a bang up job. We do keep these as interactive as we possibly can. So if you've got questions, comments, criticisms, concerns, heckling, any of the above, feel free to type it into the question box and I'll certainly bring it in. I do have some advanced questions that got sent in when folks registered. we'll try to address those. Those are more fun because I haven't given Kirk a heads up, so he'll be getting them all cold. This is the best way to do these because then, again, more fun. Last but not least, if you're not shy and you've got a microphone, there is a hand wavy icon. If you hit that little hand wavy icon that's showing on your screen right beside the word muted, then I may or may not unmute you. If I like you, I'll unmute you. If I don't like you, well, what are you doing here anyway? But absolutely, like I said, we try to make this as interactive as we can. So the topic today, and the reason I asked Kirk along, because he does a lot more speaking on this topic than I do, is we're going to talk a little bit about MPX over AES, but we're going to really focus on audio over IP and its various iterations. And so we'll talk about the different ones, and Kirk's going to do a live demo for us, which will probably take up a good chunk of the session. And we'll have some fun swapping screens back and forth too, because you know, we'll see if we can get it smooth and slick, but probably not. Again, where would be entertainment value in that? Now, Kirk, I don't know if you've ever heard this story, but and Chuck Kelly, who is now with Elenos, so credit where it's due, but Chuck Kelly, Frank Foti, and I sat down at a little Italian restaurant called Vinsanto in Middleton, Wisconsin, and coincidentally, it was during a Wisconsin Broadcasters Association conference. I want to say close to 10 years ago, but I'm guessing at that. You'd know when MPX over AES came out better than I would. Um, it was in that range though, right?
Yeah, it was. It
2008
was.
or 9?
Yeah.
And so there was a lot of lasagna, there was a lot of good wine. I was just there for comedic relief and to pay the bill, the bar tab, I'm sure. But Chuck whipped out a handful of paper napkins and said, no good idea can be done without paper napkins. And
Right.
I swear he brought them just specifically for that purpose. And watching him and Frank sit down and noodle that stuff out was just, it was really fun watching those guys at work. So that was where MPX over AES kind of conceptualized. And then next NAB, we had a co-demo of it. And I know you were around for that. You've been, how long you been with Telos now? It's been a while.
Been 20, 21, coming up on 21. Actually, it's been 21 years. Yeah, I just had 21-year anniversary. Gosh, about a month ago. So yeah, 21 years in a month now.
Doesn't time fly when you're having fun?
I've had 10 different titles there, and when they find something I'm good at, I'll get to keep the business cards for a while.
The good thing is, as long as they're keeping you there while they find you a new title, you know, I'm
That's right.
on 1, 2, 3, 4 titles, I guess, and I'm
Wow.
not sure whether it's that I'm any better or it's that they're just having trouble finding stuff where I don't irritate too many people.
Jeff, I don't know if you remember, but even before MPX over AES, there was another technology project between Omnia and Nautel to send digital multiplex information into a Nautel exciter. Do you remember that?
Mhm. The Omnia Direct,
It actually had
or
it had a
before
different name.
that, for the
I'm so sorry.
yeah, I'm going to say actually the Omnia Direct was an MPX over AES iteration and the precursor, if you will.
And actually, I'm sorry. I'm having old timers disease right now. I'm not thinking of the name of it, but no, it wasn't Omnia Direct. It was called something else.
Mhm.
And I meant to ask Frank what that was, but no, this was a highly modified Nautel exciter and a modified Omnia processor. And it wasn't the AES standard. It was our own standard that we came up with jointly to get the digital modulation information over to the Nautel exciter. It didn't take off. It was never sold, but it was a technology demonstration that cleaner frequency modulated FM audio and transmission it was possible. It was possible.
Uh, and that's one of the key things about this, because, and I mean, going back to looking at a composite, the MPX signal, there are a lot of pieces there that have to tie together.
Sure. Hey, if you don't, would you like me to carry us through some of these slides right here?
Sure, you just
Yeah.
hang on a sec. I can probably give you keyboard and mouse control if
Oh,
I don't mess this up too badly.
well, that way I won't have to say next slide, next slide, next slide, will I? I just hit it myself.
Let's see if it works.
Let's see. Oh, it's wanting me to share my screen. Did you want to do that or show the slides?
Oh, just go ahead and we'll do the slides then. Never mind.
Okay.
There. And we'll go back to, yeah, see, this is what happens, folks, when we start playing with stuff we haven't played with before.
All right. So I think we should probably start with a fundamental thing, and that is the FM baseband. For those of you who are kind of new to it, this is on a frequency basis. This is what the FM baseband looks like. This was invented to have compatibility between stereo FM and mono radio. So when stereo FM came along, well, all the radios out there were mono. So we had to make sure that we transmitted stereo in such a way that the mono radios still heard what they had always heard. So FM, the FM transmission standard, which has been around now for almost 60 years, it consists of the left plus right audio mixed together, the mono audio, and that fundamentally frequency modulates the FM carrier. So a mono radio will just listen to that part on the left side of the spectrum display there between 0 and 15 kilohertz, mono audio, left plus right. Then comes the stereo pilot, and that tells a stereo radio, hey, I'm transmitting stereo. In fact, I'm transmitting stereo. You should reference me, the stereo pilot, and my phase in order to look for the next thing up the line. Well, the next thing up the line is a dual sideband carrier with a suppressed carrier. That would be at 38 kilohertz, but we suppress the carrier. Honestly, I forget why. I don't know why, but the 19 kilohertz pilot is in the radio. It's doubled and then inserted right back in so that that stereo audio left minus right can be decoded. Now people say, well, what does that sound like? What does left minus right sound like? And many times it wouldn't sound very good at all. It would just sound like the immediate instantaneous difference between the left channel and the right channel. If you're listening to a mono voice that's properly balanced, you'll hear nothing or almost nothing in the left minus right. If you listen to a Beatles song where the voices are on the left channel and the instruments are on the right channel, or vice versa, then you'll hear just about what you hear in the mono. So you're going to hear the difference in the left plus right. And as I said, with mono programming, that information is next to nothing or nothing. And in highly stereoized information, you're going to hear some audio there, although it may not sound pretty. Oftentimes it's lacking bass because bass tends to be mixed to the center. So it's going to go in the left plus right and will not be existent in the left minus right. So that takes up a fair amount of spectrum there from 23 kilohertz to 53 kilohertz. And then above that is this newish thing that wasn't invented till later on, and that's RDS, or in the United States, RBDS. That's where we can transmit your call sign, your slogan, your title and artist information, such as that. So that's the fundamental FM baseband right there. And I want to point out something important. And I learned this from an engineer named Jeff Mendenhall, who has worked at several different transmitter companies. That baseband right there, from 0 to 57 or a little bit higher kilohertz, that's kind of fragile. Whenever we are dealing with the baseband, the FM composite, or the FM MPX, as it's often called, for multiplex, we've got to be super careful with that signal. We don't even want to run it through an amplifier that isn't cognizant of good phase response. Now, if we want anything that this goes through, it's got to be in phase. It can't have phase changes. It can't have group delay. It has to have perfectly flat frequency response. And that's why you can't just run this through an audio transformer. Okay, if you're a Bell System 111C repeat coil, and if you're old, you know what that is, then you can kind of run this through that. But the point is, we got to be careful with this whole composite signal. This signal in its analog form is typically what will go modulate an FM exciter. Right? Right. Yep. Okay. So
one other note about that, before we get too far, and we did a RDS session 3 weeks, some number of weeks ago. Yeah. And that was one of the notes there was that the RDS carriers, for example, are at quadrature to the pilot, and because if you look, 1957, that's a third harmonic. There's a lot of relationships between them.
Yes,
Stu Albert mentions that. Mm-hmm. Sorry, go.
Oh, I'm sorry. What's Stu say? It may be real pertinent right now.
Well, no, Stu mentions that suppressing the 38 kilohertz subcarrier doubles the bandwidth.
Okay. All right.
Good. We may have to unmute Stu at some point and get some information on that.
I'm sure there's good reason for it, and Stu may be exactly right. I'm not quite sure the implications of that. It's also a lot of people will add an RDS encoder to their signal somewhere. They'll put it in line with the FM multiplex, or they'll feed it into an input port on their FM processor or on their FM exciter. It's important that you either run your FM composite through the encoder so that it can pick up the stereo pilot and generate the RDS signal in proper phase relationship with the pilot, or it's important that you provide a sample of the pilot, which many FM processors give you, a sample of the pilot coming out, and feed it into an input on the encoder. Point is, it's important to eliminate the sound of birdies and to just make the data more robust. It's important to make sure that your RDS signal is synchronized to your stereo pilot.
Right.
All right.
And Florian asked if the webinar is being recorded, and I'll mention where you can find the recording later, but absolutely it is being recorded. We do archive everything that you can link to, and I see Ed's got the answer there as well. So
there's evidence to convict the guilty later on. Got it. All right.
Always. And in spite of knowing that and having done this 43 times, I still manage to open my mouth and put myself in trouble on occasion. So now John Van Milligan mentions that if the 38 kilohertz carrier wasn't reduced, you would have to reduce total modulation.
Oh, okay. So it's a technique to reduce the total modulation taken up by something that doesn't give you any audio, which would be that 38 kilohertz pilot. So that's why it's a double sideband suppressed carrier signal there for the stereo. Right. That makes perfect sense. Thanks for the extra explanation. Appreciate that.
Go. No.
I mentioned it's important that this signal is a little bit fragile. It's also any noise in this signal, any noise just from regular analog componentry or from an analog STL system, well, any noise in this signal is going to get transmitted on your FM carrier. And so if you have a noisy STL, you have a noisy FM radio station. And that is critical. It's critical because if you can transmit a clean FM signal, perfectly clean, you can actually get out farther. Your radios can pick you up farther out cleanly. It's absolutely, if you have a way to make that signal clean, do it. Okay, so here is a picture of a typical STL system. And by the way, Jeff, if you could flip back to that previous slide 1 second, I want to make one point. And that point is this: even if your FM processor is right next to your FM transmitter, and you just have an analog cable connected to, typically a BNC connection with RG58 or RG59 cable, any noise added gets transmitted. So I just really want to make that point. We really want to keep that noise down, and analog is only so good. Yes, we're really good at it, but it's only so good. Okay, next slide.
Well, just jump in there for a sec. That brings in a really good point, especially as we move more and more to efficiency of space and co-locations.
Yeah.
Then if you're running an analog plant, the shielding is critical to keep the RF off, and it gets rectified, and then the next thing you know, get 3 radio stations on one.
If you have an analog STL, and many of us do, let's say in the US, you might have a 950 megahertz band STL. Most of my radio stations do, not all of them, but most of them do, for example. Although it's getting to the point where it's only about half and half now. But anyway, any noise, an FM STL, an analog STL, and we've dealt with them for years and years, different manufacturers, famous names like Mosley or Bext. Marty has made some STLs. They're just an FM transmitter and an FM receiver. That's all they are, right? So any noise in that system gets added to your multiplex. That's bad, because you're going to transmit any noise in that system on your FM signal. So you have, relatively speaking, expensive antennas. You have RF feed line. You might have to repair an STL radio. You have RF congestion, as you know, if you're in a city. You can have atmospheric fading of your signal. Noise distortion overshoots in any FM modulation demodulation scheme, like an MPX analog STL. You're going to have overshoots, and again, any impairments directly affect your transmitted signal. Next one, Jeff.
And that's exactly what you were talking about before too. And this is the point where we kind of sat down at Vinsanto with a whole lot of lasagna and maybe a whole lot of wine. You know, again, we're being recorded. There's a limit to what I'll confess to in a public forum. But this is where the Omnia Direct, the original MPX over AES, kind of evolved.
Yeah. So what we have is a system where instead of carrying that baseband signal in an analog format, we can actually use, I believe, if I'm not mistaken, AES digital at 192 kilohertz sampling was already a standard. I don't think
Yeah,
anybody had to invent that standard. Now, this is a new use for it, right? But I
right.
don't think anybody had to invent that as a standard. So AES at 192 kilohertz sampling is a thing, was a thing.
Mhm.
And so if we take that, if we remember Nyquist and Shannon and what they postulated or what they proved about digitizing audio, remember we have to digitize up to about 63, 64 kilohertz if we're just going to carry the RDS. If you're going to carry a 67 kilohertz subcarrier, which very few people do anymore, but some do, you have to sample at least double the highest frequency expected. Well, think of that FM baseband as for 0 up to whatever frequency. Maybe it's 63 kilohertz, maybe it's higher than that. But you got to sample at double that. Well, 192 was pretty perfect for that. We could, in fact, could you even get the seconds of the 92 kilohertz subcarrier? Just about you could get that in there.
You'd have a little fading on it, but you could get pretty close.
So the point there is AES digital, you got a bit depth there. I'm not sure what bit depth they typically use for that, whether it was 16-bit, maybe 20-bit, but you sample that whole FM composite, turn it into digital samples, format that into the AES 192 kilohertz sampling rate format. This is the AES EBU, also maybe known as AES3 format. This is not IP at this point. This is just a piece of cable carrying AES digital.
Right.
Again, not IP at this point, right? And that would carry your FM composite signal in a digital format. The noise would be way down. If it was 16-bit, that noise was at least 96 dB down from the
Mhm.
top. At a higher bit depth, like 20 bits, you'd be on the order of 110, 112 or so dB
About that.
down. So you'd have really good noise figure here. And you design an FM exciter to accept that AES digital, and then inside the exciter, would it get turned back into analog? I kind of doubt it. It would then hit a numerically controlled oscillator, an NCO, and
Yeah.
numerically through an algorithm create your FM signal. Very clean.
And it's one of the cool things that it just happened that the idea came along because the exciters at the time, and of course, I'm looking at ours is my pretty much sole experience, but not just us. Most of them were becoming direct to channel. So you fed the audio in. The first thing it hit was A to D converter or some conversion. Like you said, it could have been just an NCO or a numerically controlled oscillator, whatever, and converted it directly to a digital sample that was put directly again in a computer chip through a processor of some sort onto onto the carrier frequency. So that was kind of part and parcel because at that point upgrading, and the Omnia 11 had the same concept, which is what we used to demo this, because you could almost create the technology with software. And
Yes. Yeah.
that was, you know, having the technology to do that was critical to having the concept be able to happen.
By the way, I want to point out one thing if you're a little bit new to MPX. Sometimes there's confusion about where to do preemphasis and de-emphasis and la da da. And if you have an FM processor, it has to preemphasize. It has to be preemphasis aware. It has to preemphasize in order to properly process the audio for a later FM modulator. And some people will de-emphasize that, then they'll carry it somehow, and then they'll re-emphasize it in the FM exciter. That's actually not the best way to do it. If whatever's carrying your audio can carry it pre-emphasized linearly, that's the best thing. Let the FM processor do that pre-emphasis and only do it once. Don't pre-emphasize, then de-emphasize, then re-emphasize. By the way, that's in the left and right domain. That's not MPX. What my point is this: MPX signal is always pre-emphasized. There is no such thing as a de-emphasis to carry it somewhere. So whenever you have an MPX signal, you know that is pre-emphasized, and there's no option to pre or de-emphasize that, or there shouldn't be. Now, if you want to listen to it back on a mod monitor, yes, you can listen pre or de-emphasize, but that's just for test purposes. All right, so and I even saw there's still confusion on the preempt de-emph topic, but as long as you're in the MPX domain, it's all pre-emphasized. It has to be.
Right, right. And I mean, even my preference is to do the preemphasis in the processor whenever, even if I'm working in analog, just primarily because, you know, you guys tend to massage audio a whole lot better than we do as RF people. You know, we don't work in the audio domain a whole lot. So,
It's worth stating that if a processor does pre-emphasis and then you de-emphasize, then you carry it somewhere and re-emphasize. The re-emphasis elsewhere is not going to be the same curve that the de-emphasis was in the processor. It's going to be close, but it's not going to be exactly the same. You're going to have overshoots. You
right.
have to. So anyway, let's move on from that. And my point there really was MPX is always pre-emphasized, and you don't need to touch it.
Right.
What's next?
A couple of comments here. Link Casino is asking what is KFS from my picture here, and that's kilo frames per second. And don't ask me why we use that. It's that this is a screenshot from one of our websites, so you'd have to ask. Actually, John might know because he was our marketing guy back then.
It's actually kilofrancs per second because Frank was involved. Frank Foti was involved in that. So it's his self homage.
That's the story, and we're sticking to it.
That's right.
Now, David Bialik asked if it's over AES, would it work with Dante, Ravenna, or Livewire? And
the answer is generally no. Those systems, I doubt those systems support 192 kilobits per second of a sample rate. I know that Livewire does not. It's fixed at 48. It's 48, and no matter what you want, it's 48. You can use any sample frequency you want as long as it's 48.
Right.
I believe some of the other standards out there let you switch between 44.1 and 48. I don't know if Dante will support 96. Maybe it does because it's meant for the pro audio market and not so much for the broadcast market. At least that was the original intent. So my personal guess is no, but if you have a system that you know supports 192, then yeah, it should carry it just fine. It is an AES standard.
Yeah. And so Brad is going to help us segue into the next step. What's the difference between MPX over AES and Omnia's new microMPX? And that's the point where we go from MPX over AES to MPX over IP.
I do want to point out MPX over AES, what we've been talking about, that's a totally linear thing. There's no compression done. It's 192 kilohertz sampling. It takes a full bandwidth of data to make that happen. And some of the companies, there are several companies that have been making for some years a box that will take a multiplex in and give you AES out, or even give you IP out, but they will sample it with maybe a lower bit depth than you might have thought in order to save bandwidth. They actually might cut off half of the stereo signal, like the old, I think it was the Cat Link used to do to fit MPX over a T1 circuit. So there's some tricks that you can play, and some of the manufacturers do or let you do. It's your own choice, depending on. But you're going to get a data rate typically of 4 to 5 megabits per second in a linear function. So you sample your MPX linearly, you put it over AES 192, you're going to end up with a bit rate in the 4 or 5 megabit per second range, and that's even if you're already doing a few bit saving techniques. Now we'll move into, for a lot of folks, 5 megabits per second all the time is a little much to be thinking about sending to your transmitter sites. Although, hey, it was definitely too much 10 years ago. Nowadays, we have more and more circuits that would handle that on an IP packet basis. But for a lot of people, if we could move an MPX signal at a much lower bit rate, wouldn't that be convenient? Wouldn't that be cool? Wouldn't that open up a lot of possibilities? Especially if we could do that with some redundancy of signal. So if we could maybe send 2 of these out and then do packet combining or packet replacement at the other end, that would be good. So looks like we're starting with this slide here that Jeff has put in. There's a technology called microMPX. And I really need to tell you what microMPX is not before I tell you what it is. MicroMPX, well, it is a way to take a full MPX signal and what would have resulted in 5 or more megabits per second of digital data to represent the MPX signal. It's a way to trim off what you really, really don't need and move that data at a much lower bit rate, which is much more convenient for people. And now, of course, the first thing everybody's thinking is, well, yeah, but how does that sound? We all know that when codecs get real slow, low bit rates, that sounds bad. And we're talking about a big signal here with this MPX. You've already said so yourself, Kirk. Well, yeah, okay, that's true. But here's what microMPX is not. MicroMPX is not a psychoacoustic algorithm. It does not remove data based on what it supposes you can't hear. So it's not MP3. It's not MPEG layer 2. It's not AAC. It's not any kind of a psychoacoustic algorithm. And that means that it doesn't make any decisions about what you can and can't hear as the other lossy codecs do. Now, microMPX is a lossy codec. It's a mathematical design. And in a few slides, hopefully I'll get to tell you a bit more about how it does this. The bottom line is what you get at the other end is not bit for bit what you put in, but it is extremely clean. And in some ways, it may be cleaner than what you gave it. And that's what? How does that work? Well, so let's move through this and talk about it. So this slide here, where I'm showing you, you can have this Omnia MPX node as an encoder, and a similar looking one is the decoder. I got to tell you one other misconception. A lot of folks look at this and say, oh, do I hook this to my live wire? And the answer is no. The Omnia MPX node has no live wire in it or out of it. We put it in the same, my employer Telos, we put it in the same box because it was the right size box and we had a lot of them. Okay. So but it has no live wire. It does have IP, yes, but it's not a live wire device. On the back of the Omnia MPX node is a BNC connector. It'll work with any FM processor. It does not have to be an Omnia processor. It can be anybody's FM processor. And shown here on the slide, you see analog MPX coming out of, I showed an old Omnia processor, right? An Omnia 6. And you plug that into a BNC connector on the back of the Omnia MPX node. Then you configure the node, and out of the node comes an IP stream of anywhere from 400 kilobits up to about 600 kilobits, depending on how you configure it. And then you send that to the transmitter site, where you have a similar looking box. It's actually the same box with some jumpers in different places. And the IP goes into it, and what comes out of it through its BNC connector is your analog MPX signal, but it's really clean. And that goes to your transmitter. So let's move on. Oh, and you can have 2 links if you want to for redundancy. Our good friend Tony Peterly has shown us how reliable that can be through some cool demonstrations. So yeah, let's move to the next slide. Oh yeah.
Well, before we get there, I've got a bunch of questions coming in.
Okay.
So in full disclosure, because again, Kirk is catching all this blind for the first time. So he sent me a slide deck, and I pick and chose the.
I figured.
It'll surprise him. Anyway, Brian's asking, does Omnia have an MPX node decoder in the works that would have an MPX over AES output rather than analog only MPX output?
I could tell you, but I have to shoot you.
Sorry, Brian. Well, we like Brian. Brian's a good customer, so we're not to shoot him just yet.
I actually have no direct knowledge of that, but it makes absolute sense that we would. So,
yeah. I mean, especially with more and more transmitters able to handle MPX over AES natively as a direct plug-in, it cuts you down on the noise on that last length of wire.
It would, yes.
David's got a question that I'll get in a second. Marco asks if there's a picture of the back of the MPX node, and in your slide deck there was, in what I copied there is not. So Marco, either we will try to find a way for me to bring that up on my screen, or we will give you a copy of the slide deck after the fact.
And to answer Marco's question, it's actually really simple. There's a power connector. There's 2 network connectors. There is a GPIO connector. It does not carry GPIO end to end, but it gives you GPIO. You can shut it off, shut it back on remotely. It can give you status. Hey, I'm getting a bit stream. Oh, I'm not getting a bit stream. And then it has the BNC connector. What's a little confusing is the BNC connector is either an input or it's an output, depending on how you have some jumpers set inside. So it's only got one BNC connector and it serves a dual purpose, not at the same time, but the encoder hardware is precisely the same as the decoder's hardware. It's just with different jumper settings inside.
Yeah. Brian says if you did have the AES over MPX output, he'd buy it tomorrow.
Gotcha.
So
Good to know.
note for the marketing folks. Brad says even though the, yeah.
Just one thing. I realize that the Omni MPX node probably doesn't have a bunch of features that people want. We built the first one to be cheap and cheerful. Its whole motto is cheap and cheerful. Here's what it does. It solves a problem for 70, 80% of broadcasters, or at least it solved it for me at several occasions. I'll tell you about that later. But we realize it's not everybody's perfect, complete solution. And so, it's crawl, walk, run. You want to see, hey, is this product going to sell? If it does, then we'll build a newer, better one that does more things later on.
Yep. Brad mentioned, so even though the MPX node isn't LiveWire, which makes sense, can one of the network ports be configured to coexist with your existing LiveWire network?
Well, the answer is yes, because any IP can coexist with LiveWire. Conversely, LiveWire can't necessarily run on your business network because your business network switches may not be qualified to run AOIP, whether it's LiveWire, WheatNet, Ravenna, AES67, doesn't matter. Any IP network that works for AOIP will work just fine for printing your documents too.
Yeah. And let's see, Javad's got a question about handling HD1s, and Javad, that's so you can encode both FM and HD1 into MPX over AES. And Javad, I can answer that one because for HD1, that is AES only. AES EBU is the format, and that's what you've got.
Again, this box is only meant for the analog portion of an FM radio station plus RDS, and so this box has zero to do with HD. Zero. It's really not even meant for stations that are doing HD.
Right.
You could, although the latency through an Omnia MPX node through the microMPX system, the latency is not necessarily fixed to the microsecond. It may move around a tiny bit, so it's really not meant for use as part of an HD system.
Right, exactly. And all right, now I'm going to kick it ahead a notch, and this answers a question that David Bialik had asked. Can you distribute a single MPX signal to multiple stations?
You can, and there's two different ways to do that, David. One way is through multiple unicast. So that's not what I'm showing on this particular slide, but multiple unicast. The Omni MPX node as an encoder sends RTP UDP streams. So they're not TCP, they're not shaking hands. It just sends the data to the IP address and port number that you specify out there in the public world, or over a private WAN, or over VPN. And I would, if you're concerned with security, I would have VPNs at all these sites, private VPN back to your home location. But the Omni MPX node encoder, as it comes, will send, I believe, to 2 locations, and you can buy licenses. They're fairly cheap to enable more sending. I think it'll send on a unicast basis up to 8 different locations, up to eight different IP addresses, or 8 outputs, whether the same or different IP addresses. So that's multiple unicast, because the public internet doesn't handle multicast. But if you have a WAN, or if you have some kind of a VPN, that will handle multicast, or if you have a private WAN, as I was mentioning, or a software-defined network, then yes, you can feed one multicast address out of the box and have units in other cities subscribe to that IGMP group, that multicast address. I believe there is a license fee to turn that on the decoders. It's not expensive. It's incidental almost, but it doesn't come standard. So either way, multiple unicast or true multicast.
Right.
All right.
Oh, Javad clarified that he meant sending the HD1 and the FM over the microMPX. And the short answer, Javad, is you could, but then on the receive end at the transmitter site end for the HD1 feed, you'd need to decode it and convert it back to conventional AES. Because the HD1 travels over an IP link, the E to X, the export to XGen is an IP stream by default. it would make much more sense to put your HD multicast or your HD generator, regardless of what brand, at the studio.
Yeah.
Then you could use your MPX node to handle analog or AES over IP for the analog feed to the transmitter, and just send your HD data as a separate digital feed.
Yeah.
And they can all go over the same pipe. So it would be a whole lot cleaner that way.
Yeah.
All right,
Yeah.
very good. Moving forward. So, but this is the cool thing about this, that you do have the ability to do. You can feed your main, your backup, all from one source without a whole lot of switching and jumping through hoops. And it really lends itself to both virtualization and hot switching your backup sources.
What's next? Oh, okay. So thinking about producing your broadcasting from a total cloud environment, whether it's a private data center, maybe this is at your own radio station, or maybe it truly is a public data system like Amazon or Microsoft Azure or Google Cloud. Think about having your automation system in the cloud. Think about having your FM audio processor in the cloud. And certainly my employer makes these now. You can have Omnia 9 running in a cloud environment. And the cloud processors, at least from our company, can generate microMPX. It's typically a licensed add-on, not expensive, and you can add that in there. And so now you never once enter the multiplex domain, at least as a physical output. You just spit out microMPX and then send that to your transmitter sites in the physical real world and decode that and put it on the air. So I just want to show this as open your mind as to a possibility. Yes, you can run very sophisticated audio processing in a cloud and get microMPX out of it, and it's going to sound really clean on the air.
Yeah. Now, question just came in from Dave Hartman that is a really good one for the US-based folks. Is there an easy way to get your EAS alerts into the air chain with a system like this?
At the moment, that answer is no. I should say, is there an easy and fundamentally legal way with the way the rules are written right now? No. And that's not Telos or Omnia's or Nautel's fault. It's the way the rules are written. And I'm not sure if I agree or disagree with the rules. I'm just going to say the rules are pretty rigid right now as to how you must monitor and insert EAS. You better believe there are talks in the industry going on about maybe making this as reliable, but a bit more flexible in how it's done.
Right. Now, a side note about that, if you're doing a multicast situation where you're feeding different cities, you could put an EAS encoder at each transmitter site, use the beginning a message status output on the EAS device to trip a preset on the transmitter, use the end of message to put it back to the original preset, and just feed the EAS as the audio source for the quote unquote EAS preset. And now, I mean, I know we can do it. I am pretty sure that most of the other transmitter manufacturers have similar setups.
And lots of transmitters, yours especially, Jeff, you can switch inputs, you can switch presets. You could even switch to, let's say you wanted your EAS to be properly processed audio. You guys offer FM processors built into the transmitter. You could normally not use it, but when you switch to EAS, you would be using it. So there, and it would sound, like the rest of your programming, well, except it's EAS. Yeah, it's possible. There are ways to do it. The micro MPX from Omnia has absolutely no provision that'll help you out with that whatsoever. There's no point where you get left and right separate audio in that domain. The whole point of this of at least the current iteration, the first iteration of Omnia MPX node, is that it's a pipe that carries MPX, just like your STL doesn't have any way to insert EAS with it.
No. We're running quarter to the top of the hour. We're of course going to be, no, don't bear with me. We're going to be 10 minutes late because we always are. And why would I change now? But there are a couple other questions that I want to hit that are a good segue into handing over to you for the live demo. So Jerry mentions he's just getting ready to switch over to an MPX over IP system. And what are some good items to have in the toolbox for testing and troubleshooting? And I mean, the first thing that came to my mind was Wireshark, because when I'm looking to see where the bits are going, that's my go-to.
And see, Wireshark is too complicated for me. I've looked at it and tried it, and I'm thinking I could
There's a
learn this, but
lot of stuff.
I
There's
don't
a
have so
lot
much
of stuff.
time. So actually, I have had to do some troubleshooting. I've thought I was sending the stream out of my MPX encoder, and I wasn't getting anything being decoded at the decoder. Why was that? Well, of course, you need to do a port forward, and you can choose any port you want. Some high numbered port would be a great idea, something that the script kiddies aren't likely to be pinging on. Doesn't mean you're totally safe, but and in my situation, I'm using this over public internet. I'm not using it in a VPN situation. I should, but I'm not. I use some tools that are built into my router. And for example, just a count of packets going by on a given port number, for example, or from a specific IP address or to a specific IP address. I'm using MikroTik routers, and so they have quite a bit of tools that I barely understand that are good enough for me to get in there and look and see. Oh yeah, I'm putting out data on this and so port number, and it's pointed at that IP address. Oh, I fat fingered the IP address. I'm hitting Mrs. McGillicuddy's bingo game right now with, with microMPX. So I'll stop that and I'll quit fat fingering the IP address. Most problems here, by the way, are fat finger problems. If you got a port forward going from your router, this is on the receiving end of the transmitter side, going from your router into your MPX node, which needs to have a fixed IP address on the LAN, so you know where to forward the packets to. Well, if you don't fat finger that, so to speak, then you should be fine. You're going to get if the packets appear, they're going to get decoded, and
Yeah.
that does bring us to a good segue, I suppose.
It does. Now, let's see. Brad mentions for the MPX and HD question, he's been configuring out a system using an Omnia 9 with multi-stream at the station side. Side note, I love the Omnia 9, by the way. There you go, a little plug there, because it can do everything.
Yeah,
But
yeah.
processor outputs both AES for HD1, HD2, and microMPX for the analog side. Pipes over a private WAN to the transmitter site, microMPX decoder node into the analog part of the transmitter, AES node feeding the HD importer, feeding the XGen. So again, where you put the pieces really is limited by both your infrastructure and your imagination. I mean, there are a lot of ways to make this stuff work together. One other note before we do the segue, recommended devices that will deliver MPX via either IP or AES in a high RF environment. And that's one of the benefits of the MPX over analog. But is there anything that's a little more RF proof than other things?
Well, he kind of asked a broad question there. Other manufacturers, WorldCast System, Gates Air, then there's a European concern that also makes boxes that do MPX over IP. Then there's the Omnia that does micro MPX over IP at bit rates in the 400 or 500 kilobit per second area, which is advantageous to me because I can easily use public internet, wireless ISP, to get things there, and I'm not chewing up many megabits of bandwidth. And there's forward error correction, and there's the possibility of dual link. So all that adds to reliability. RF, well, our node boxes. I'm speaking of Telos stuff now. The box that the LiveWire nodes come in, and same box that the MPX node comes in. These were engineered for high RF environments anyway.
Yeah.
And there's a real benefit in IP connectivity. I'm not saying that it can't be overwhelmed by RF. Yes, it can be, but it's Cat5 cable is inherently balanced. It inherently has a transformer or perhaps a solid state transformer in at each NIC, input and output. I'm not saying they can't be overwhelmed, but they do have a very high degree of common mode rejection. And I'm not saying I've never had a problem, but I've had rare problems with RF and IP in the same environment. Yes, it can happen, but I've always solved it with a little. In fact, the last time I solved a problem, I grounded my MikroTik router to my Nautel transmitter. Got them singing the same ground song, and bam, no more RF problems with the IP link. So
Yeah. Uh, let's see, a couple more quick questions, and then we're going to switch over to you. Plans to offer a built-in MPX IP encoder for the Omnia 11. Funny, I got that question twice.
To my knowledge, that is not in the game plan. The Omnia 11 is pretty much fully utilizing the hardware that it's built on.
Yeah.
And now, that doesn't mean there won't be products down the road. Most manufacturers can only. I'm not saying there's an end of life for the Omnia 11. Don't misread me, please.
Right,
we have
right.
plenty of parts to make that, but there's always something new coming down the pike.
Right. And let's see, if I'm sending the full 0 dBFS at 24-bit, how will this be decoded in the Nautel transmitter? Well, when you hit all ones, you've hit all ones. There is. What happens? Somebody mentioned, I read an article the other day, and they said if you go past all ones, and it's like there is no mode that goes past all ones. There's no 2 in digital. So will it clip? Well, that is $1 billion question. It's going to distort. How that distortion manifests is,
In the and I'll speak about the product that my employer makes, the Omnia MPX node. In the Omnia MPX node, there is one and only one place that you could possibly clip, and that is on the analog MPX input coming into the node, acting as an encoder. And there is a control in there, and there's a clip light, and you want to set that, with heavy processing or whatever you're going to do, and you want to set that to where you're still several dB below. Below 0, and once I've set it correctly, I've never had a problem. It's on the output of the decoder node. You can crank the output all the way up, but to my knowledge, you can't crank it up beyond the analog circuitry's ability to turn that back into analog.
Right. Okay. And so just for reference, if you do tap 0 dBFS, that's not clipped necessarily. It's when your input tries to go at such a level that would drive the A to D converter beyond that, assuming that there were a beyond to that.
If there were a beyond, that's right.
Yeah. Okay, so at that point, I'm going to flip control over to you, and we are going to see if we can't do a little bit of a live demo.
Yeah, so I'm going to show you a couple of things. Let's see. Jeff won't request keyboard and mouse control. Did you really want keyboard and mouse control?
No, decline that.
Okay. All righty. So you should be seeing my screen. That is the decoder. But I'm going to actually flip away from that and go over to the encoder. So at one of my radio stations, we operate an AM station, and we have an FM translator that is not co-located with the AM station. And so we take our AM, it's a news talk, so you may occasionally see absolutely dead air here, because that would be dead air during it, like you're seeing right now. You're seeing some short periods of silence. What you're looking at here is the display from an Omnia SST FM audio processor. This is a product that Omnia sells. It's fairly inexpensive. It runs in Windows as a service. It's not an app, it's a service. I've got it running here on an old used Dell R710 probably server. I'm going to go back here and just show you here's the main screen for it. Looking at the input, cleanup processing, audio processing, for example, we can look at that. Adjustments for phase, EQ, AGC, multiband, blah, 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 all the usual things that you'd have in an FM processor. But I'm not going to worry about that right now. We're going to look at, it has RDS as well. But I'm going to go to the microMPX part. And this is an option. You got to get a license to turn this on. And so here's the left and right audio input coming into it. And there's the input you can see as an oscilloscope. And here's the output of it as a stereo generated. So that's an MPX oscillogram picture there. And then let me slide this over to the right. There it is in the frequency domain. And you can see how sharp the filtering is around the pilot. And then so there's the pilot, which looks a little high to me, but it's set, I believe it's set at 9. And then there's the RDS that we're transmitting. So I know you can't see much here besides, hey, well, that looks like a stereo generator. What's different than being a stereo generator with an RDS encoder built in? Well, here under microMPX, you see I've got it set to 320 kilobits per second, which is the the standard rate. I could go higher. There are options to put that up to higher bit rates. Because of the certain particular challenges that I have with this link, this is actually going through 3 or 4 different ISPs. It goes from Greenville, Mississippi to Dallas, Texas, to New Orleans, Louisiana, to Jackson, Mississippi, to Itabena, Mississippi, and then 3 microwave hops later, it shows up at our translator site.
Well, if
Yeah.
anybody heard your crock pot joke, you're going to be worrying about that signal all day.
I'm not going to show it to you because I'm a little paranoid about it, but if I scroll down where it says streams here at the bottom of your screen, there is an IP address there with a port number, a very odd high port number, and that is where I'm sending this stream. It is 320 kilobits per second, and plus some error correction. I'm doing forward error correction. I'm doing quite a bit of it. In fact, I've got it cranked up to about the max, which almost doubles the bit rate. So I'm sending about 600 kilobits per second from Greenville, Mississippi to Cleveland, Mississippi, and going through a whole bunch of hops to get there because we can't get on the same ISP at the moment at both ends of this thing. We will be at some point, but not now. Okay, so let's move on to a different screen. Let's move to the other end of this whole affair, and this is the decoder. This is the piece. Oh, now let me make it real clear here. On the encoder, this is built into the audio processor. This is running on a Windows machine as a service. So a whole FM processor, multi-bands, FM clipping, FM stereo generation. Hey, if I needed an analog output from this, I would buy a USB sound card that could do 192 kilohertz sampling, and I would come out either the left or the right channel, and it would be a multiplex signal coming out of there, right up to 60 some kilohertz for the RDS. It would have it all in there. But I'm not doing that. I don't need an analog output. I don't have an analog output on this computer. I don't have a sound card on this computer. I just have the IP coming out, and it's coming out at 320 kilobits per second plus the error correction. By the way, you can set the keyframe interval. This is I chose, well, for whatever reason, I chose every 2.9 seconds. I'm sending a whole block of data every 2.9 seconds. And for the next, 2.899999 seconds, I'm sending delta or changes to that keyframe. If you've ever done video editing, you're familiar with the concept of keyframes. So this is coming out. I'm not showing the IP address it's going to, but there you go. Maybe you'll see the IP address here. I don't know. So here we have the decoder. This is a piece of hardware. This is the Omnia MPX node, like you've seen the pictures of. And this is the top left display is the data stream. When you see little yellow dots, those are lost packets. Okay, they were lost somewhere in that long trip to Dallas and New Orleans and everywhere else. Then you see the decoded waveform and you see the decoded MPX signal there. Down in the lower right, I realize it's real hard to see it, but in the lower right is a numerical display of the number of packets received. I wish this was a longer window, but it shows me, I don't know how long the window is. Well, it's 1,024 packets, however long that is. If it's a second, if it's 2 seconds, if it's 3 seconds, 4 seconds, whatever it is, it shows me how many packets I've received out of 1,024. And the number of packets recovered is shown here. So there's 2 recovered, there's 0. As long as 1024 equals 1024, there's none to recover. Oop, there was some silence. I got a really bad hit on the data there. But typically this is going to run anywhere from 5 to 6 to 25 packets that are lost and recovered. Typically, I was real surprised to see that played silence. But if there's not enough forward error correction to take care of a whole bunch of lost packets, then you're going to see some silence played right there. And the number of keyframes received should be it'll bobble between 3 and 4, depending on the amount of time that the window is. So
right.
this
now, Marco's asking, what are the blue vertical lines on the data stream?
Oh, good question. Those are the keyframes. So they look like they're more often than every 2.9 seconds, don't they? Yeah, they do. I don't know. I thought they were the keyframes. So I don't know why they're appearing. If I'm counting how often they're popping up, that looks to me like more often than every 2.9 seconds. So sorry, I thought they were keyframes. Maybe not. It's nice when that green line in the upper left is nice and flat, but it's not. And down the bottom right, there's 4 packets lost, and there's 6 packets lost, 2 packets lost, 5 packets lost. But forward error correction, what a beautiful scheme. does a great job of recovering the data. And normally this plays back absolutely perfectly. I want to point out that on the MPX display in the upper right, you really do have a 90 to 100 dB of noise floor. It's way down. Jeff, did you keep that slide from our friend Mike Modney? Did you keep that in your deck or not?
It's not in this deck, no.
Okay,
No.
okay. There is a separate presentation that I've done with a Canadian broadcaster, Mike Modney, and he happened to he was replacing an analog composite STL with micro MPX. And on the composite had a good signal. It was, 800 microvolts or so. It was a good, strong signal. And the noise floor was about 70 or 75 dB down. And, that's perfectly normal for a composite STL. But with the microMPX, you could see the noise floor as measured on the Nautel transmitter. The noise floor was down right at or very nearly 100 dB. And so that's noise that his FM transmitter is not sending anymore. Now I realize it's way down, but every little bit hurts. Every little bit of improvement helps. And that's a lot of, 25 dB is a lot of improvement.
Yeah. Now, Brian mentions that the keyframes are the little vertical tick marks in the data stream. And
Oh, yeah, okay, okay. There they are. Okay, so there's one right there.
And see.
And there's one right there. Yeah.
Yeah. And Javad wants to know, in the encoder MPX display waveform, that's showing what it's sending, correct?
Yes. So there's the encoder right there. That's what it's sending.
Okay, very good.
Now, okay, so I said something provocative a while ago, and that was that, hey, there's no psychoacoustic bit rate reduction going on here. Okay, so Kirk, what is it? Well, of course, that's proprietary. I'm not even sure I accurately know what it is. I think I do, but I'm not even sure it's accurate. But here's the engineering explanation that I think is good enough for, it's good enough for me. It should be good enough for about anybody. The bit rate reduction that's going on does create some noise, but quite by a wonderfully happy circumstance, the noise that's created falls outside of any place interesting in the FM baseband. Now, that's one reason why we're able to heavily filter the area around the pilot. And we're able to heavily filter the area above RDS. That's where the bulk of the noise floor falls. And we do a great job of filtering that out. So sonically, you're not going to hear differences between this and a linear MPX stream, especially if you choose the 320 kilobit, which is called the standard encoding, back over here, 320 kilobits per second standard. If you choose that, to my ears, that's kind of the bottom end of where you want to be. You can easily choose a higher bit rate up to 400 kilobits per second. And these do make a slight difference, although I've been told nobody can hear the difference between 340 and 400 kilobits per second. I'm told that. I don't know if that's true or not, just to have no idea. What did I do? Let's get that back. There we go. But I chose 320 because on this link, I need the least. I've done this over a regular IP radio link, and of course I chose the highest bit rate because it really didn't matter. The IP link didn't care if my total bit rate was 600 or 550 or 320. It didn't matter.
Yeah. Now, Brad's been busy researching while we've been talking, and he mentions that the blue lines are error correction packets.
Oh, okay. Okay. Cool. Perfect.
All right. On that note, I am probably going to head to our closeout because we're 6 minutes past the top of the hour. So I will grab control back. I do want to thank you for that because that's it's always cool to be able to see the stuff.
And by the way, I want to reiterate, you're looking at a station that's on the air. It's one of my news talk stations in Mississippi.
I did a demo of the user interface on one of our boxes for somebody recently, and he goes, "Can you turn it off?" And I said, "No." Same situation.
Jeff, the takeaways that I think people should have from this is if you can, we're always looking ways to make our FM sound better. And we've been using analog MPX for years and years, and it's been okay. Will you hear a difference if you go to an AES signal, just an AES EBU 192 kilohertz signal? Omnia Direct is one brand name. Other companies have their brand names as well. But AES 192 for MPX. Will you notice a difference? If the air chain feeding up to that point, if your music is clear, if you're using good processing, if you're largely digital through everything feeding up to that point, yeah, I think you will hear a difference. It really is clean. I've heard stations, some of my own stations where we've done this. I think, wow, that's really the best I've ever heard that ever sound. And so getting into the digital domain with a Nautel exciter and an Omnia processor and going AES, let's say that they're co-located, right? If you go between them at 192 kilohertz AES, yeah, it's going to be cleaner. You really should. Your stereo signal should actually get out farther. I don't mean the RF. I mean the readability of it by radios should go farther out because it's so
Yeah.
clean. If,
Well, and that
however,
comes
yeah,
back to the AM noise thing with tube rigs. I mean, and that's one of the things you notice is you bring the AM noise down when you go to newer transmitters.
yeah.
It does make a difference in how far the signal is recoverable.
And then if you don't have the luxury of putting your exciter and your audio processor together with a AES digital link between them, then there is I mean, there's linear ones out there that take many megabits per second to get MPX over IP. And then there's Omnia's microMPX, which is just amazing and does it at really reasonable and doable bit rates. And what you
Right.
end up with is extremely clean.
Yeah.
Oh,
So, yeah.
and microMPX does carry your RDS. You want to know the dirty secret about the RDS? The secret?
No, tell me.
We don't actually sample that RDS signal way up there high at 57 kilohertz. That would take a lot of sampling and take a lot of bits to represent. We actually just decode that into the freaking ASCII data. We send that and we just recreate it at the other end. That's a whole lot less data than sampling
Right.
the freaking RDS signal. So that's one way that the microMPX algorithm saves data. That doesn't transmit that little part of the spectrum. It decodes it, sends
Well,
a few bits. So there's a number of tricks like that. The other thing I want to point out is there are some processors on the market. Omnia has some, I think other brands do too, that are really working hard to fill the envelope, the MPX envelope, with lots of audio. They're using
yeah.
opportunistic analysis to get the most loudness at any given second without processing harder. That's the cool thing.
Yep.
You may have heard of
Yep.
Omnia's One Louder or some other technologies. These are techniques for squeezing more audio in without processing harder. And then that's how a mod monitor using using an Omnia 9, you can have decoded left and right at 135% modulation while the main carrier is modulating 100%. It's freaking
Yeah.
amazing. Well, here's what I want to say. microMPX carries that along with it. You don't lose that sophistication in your processor when you carry it with microMPX. So you don't lose anything.
Right. And that's one of the cool things too in the data world. And I mean, just a little side note, like going back to the original HD signal where you had a big burst of data and then 7 frames of near silence and then another big burst of data. And so if you're running over a 500 kilobit link, you were challenged sometimes.
Mm-hmm.
And I mean, our Philip Schmidt came up with the reliable HD transport, just repackaged it into 160 kilobit steady data stream. And yeah, so same data, just different format. So it is kind of cool. Now, I will note that we are 10 minutes past. Like I said,
Yep.
that's where we go. That's the 2:10 is the new 2 o'clock in the Atlantic time zone. But this webinar, as with all webinars, as was asked earlier, is archived. You can find it by clicking the link on the resources tab of our website. You can go to our YouTube channel. We do have the Waves newsletter. I think Fiona's going to be nagging me for some content for that in the near future. And all kinds of online info. We've got a link there to Barry Michigan's BDR, Broadcasters Desktop Resources Good, radiolists.net, several Facebook groups. I know I've seen you in the Broadcasters Club and the Transmitter Sites page. There's so much out there for resources. Sometimes it can get overwhelming. So, folks, we absolutely thank you for spending an hour of your day with us today. In Kirk's case, even more. So, Kirk, I want to thank you for being with us. It's been a whole lot of fun.
Always a pleasure. Did we get the questions all answered?
I believe we did.
Okay.
Just let me take a quick scan just in case. Why are they using digital MPX when they set up analog FM SFNs? Oh, and that's more related to our Digidia Sync FM product and digital MPX for that one primarily for the same reason, because when I've got two ones, I can phase shift them a little and still see a one. Whereas in the analog domain, I create distortion at that
Yeah.
point.
Interesting.
So, you
Yeah.
know, it's the same reason for HD SFNs. They tend to be a little more forgiving than an analog SFN.
Isn't it interesting that
So,
when we have a digital signal, we can actually in some ways be a little sloppier with it than we could have with digital and still come out with a better signal than analog would have given us.
right.
Or that's,
Now,
you know,
not saying we should be sloppier,
yeah.
but at least, well, the cool thing is because then we can accommodate physics, you know, those pesky laws that just seem to resist being changed. So that is cool. Folks, I want to again thank you very much for spending some time with us, and we hope to see you next time. Have a
Take care, Jeff.
great day now.
Bye.
Bye now.